The optimal dynamics planning system, the case for automation. So we're all familiar with these rooms full of people working at computer screens, information's popping up and we're making decisions. This is a very manual process. I mean, it was high tech 20 years ago, but now this is starting to look like a very manual process, and we'd like to challenge ourselves to take this to the next level. So in manufacturing, the next level might be robots acting on cars and building them. Works much more quickly, precisely. You get a uniformity. So this is our goal in the setting of making decisions with information. So let's consider what a truckload carrier faces. Here's a number of drivers and loads. And as people work through a number of assignments over the course of the morning, we might end up with a situation where we have some drivers stranded near the coast and loads stranded in the Midwest. This is not a very good solution. Now, if we use an automated dispatch system and optimize across everybody, we can coordinate all these assignments, get all the drivers assigned, get all the loads covered, and we can also adapt as the demand patterns shift. If we have a surge of freight in the Southwest or the Southeast, we can still make the entire company work together. Now, we're also thinking about the future. Decisions on Monday, we have to anticipate what's going to happen on Tuesday or Wednesday. Now, when we do this planning into the future, if we start off at a base where we're not looking in the future, and these are the results from 11 different carriers, we have an optimized solution, but we're not looking in the future. But as we plan into the future, we can get improvements of 20 to 40%. And this is what we can get with automation. Now, how do we make this happen? So here's a simple dispatch screen. Let's say at the top we have a driver assigned to a load. Now, we may have this issue that the driver doesn't want to move that particular load. So we can click on that and come up with a ranked set of loads where the top one is the initial load and the others are second, and third, and fourth choice. Now, the way we come up with these things is we consider not only the preferences of the particular driver, what's good for the driver, we consider what's good for the entire company. So we may want to have a ranked list for one driver, but if a driver comes up and says, I don't want to take a load, we have to understand that there's a ripple among other drivers and loads. We pre-calculate that whole ripple effect before we decide what's a second choice and what's a third choice, because it's not the second choice for that driver, it's the second choice for the entire system. Now, assigning drivers to loads still involves a juggling act, minimizing empties, maximizing revenue, minimizing time window violations, getting drivers home, and maximizing driver income. We have a balancing act. A lot of people think, oh, real-time dispatch will minimize empty miles. Well, no, that wouldn't be a very good solution, because as we cover more loads, we're going to have more empties. We may even have more empties per loaded mile. It all depends on what your priorities are. What I'm going to now do is run through a number of the benefits of simply having automation, because I think that this is what we need to understand, is that there's a very important value of simply having an automated process. For example, benefits of automation include facilitating growth. As your company grows, you don't always want to add more and more overhead. You get better productivity out of your driver managers, and so that you can minimize this type of overhead. You get consistency. Let's just face it, driver managers are people. They're each going to have their own styles. With a computerized automated system, you apply one style that adapts to every driver and load in the system. Now, automated systems cannot talk to drivers, but as you free up the driver managers from having to do all this juggling, they have more time to work with drivers, talk to them, understand what their needs are, and hopefully reduce the driver turnover, especially with the younger drivers. Now, you're going to have a turnover of driver managers. You can have a nice experienced manager, and then he leaves for whatever life reason, and then you bring in somebody new who has to be trained from scratch. With an automated system, we have that safety net. You're not as vulnerable to turnover. Your major issue with new driver managers is getting them to know the drivers. Simulate first, then implement. This means we can test ideas in our digital twin technology. We can simulate dispatching and tweak knobs and try out different ideas and run very, very realistic simulations before we go to the field. So we stop playing games and experimenting with your company. Adapting to changing conditions. We all know that truckload trucking has to respond to the economy. It has its surges and recessions. With the automated system and the digital twin technology, we can test what's the right number of drivers, where should they be, what's the effective loads on the system, respond to these changes before they're happening so that you're not suddenly saying, wow, I just have too many drivers to the loads or too few. Everyone is different. Now, this is a really big issue. Every driver has their own. Some drivers want to get home every night or every 2 nights, and some just want to get out and make a lot of money. Shippers are all different. Some of them really want that on-time pickup, and others are much more flexible. What they'd really rather have is a lower rate. So it's very hard for driver managers to juggle to the needs of every individual driver and shipper, but automated systems can. We can code the rules for each individual driver, each individual shipper, and the automated system can juggle across that. Now, self-dispatch, what we really want to have is where we bring up a ranked order set of loads for the driver and let him choose. Now, we're not just throwing up loads on a load board the way a load board might. We've got this rank list logic where we're giving the drivers choice, but they're carefully chosen. And we're presenting them in an order where we're hoping that they choose the loads more to the top, and we've already optimized so we think that the driver will want that top load. But if for some other reason he wants farther down in the list, at least we're encouraging them to work with loads that work best for the entire company. We're planning into the future. We can think about what might happen. We don't know the future, but we can create expectations and help the driver figure out when he can get home and how much money he might make. Performance metrics. It's really hard to evaluate any driver manager. Each one has their own style, but they also have a different set of drivers in different regions. And everyone will say, well, I have more empties or less empties or whatever, just because I have a different set of drivers and they're in different places. The automated system, you don't have that issue. It's always applying one set of rules across the entire company. Generalized learning. As the driver managers make mistakes and learn, you've improved the performance of that one manager. As we see the model making decisions that we think that we can improve on, we've improved the whole model for the entire company. So this is where we get the generalized learning, and over time the model will be constantly getting better, and then as people leave, the model's still just as good, and so you don't lose that training. We also have crowdsourced learning because we have a number of competitors using this system, and while we cannot share data about drivers and loads and pay scales and things like that, all the carriers benefits improvements in the models and algorithms, communication with TMS systems, enhancements to reporting displays. The raw technology impacts and benefits everybody.